Alright, let's look at a more difficult difference quotient. I'm going to walk you through here and hopefully it won't be too bad. We're going to find the difference quotient when our original function is a fraction, when it's a rational function. So let's get started here with this first example. F of x equals 2 over 5x, and we want to find the difference quotient. So first thing we're going to do is set up the structure of the difference quotient, which is a fraction. So I'll set it up kind of like this. And the whole thing is over h, so I'll go ahead and put my h on the bottom. And now I'm going to work on the f of x plus h part up here in the top left corner. F of x plus h means go to the f function and plug in x plus h for x. So what that looks like is 2 over 5 times the quantity x plus h instead of 2 over 5 times x. So that's the f of x plus h portion of the difference quotient. That's one of the most missed parts of the difference quotient. Then I have to do minus f of x. Well, f of x is literally just 2 over 5 times x. Okay? So now we have it all set up. So that's kind of the easy part. Although a lot of people miss the f of x plus h portion, make sure you get that first. But other than that, every difference quotient problem is set up like this. Now it's just a matter of simplifying. And the reason I said this is one of the more difficult types of difference quotients is because, as you can see, you have fractions within fractions. In my experience, students don't like just fractions, but now you're throwing them into other fractions. So let's get started with this. How do we do this? How do we simplify it? Well, what we need to do is we need to combine the fractions on the top. And since we're subtracting, if we're adding or subtracting fractions, we need a common denominator. And I assume you've got some experience with this. If not, you might want to go watch some videos on adding and subtracting rational expressions. And in fact, when you have fractions within fractions, that's called a complex fraction. So if you need to do some research on adding and subtracting rational expressions or simplifying complex rational expressions, you may want to go do that as well. But I'm going to cover it all in this video as it pertains to the difference quotient. All right, so if I want to combine the top two fractions with a common denominator, what I have to do is I have to multiply each of them by something, and I'll multiply it in red, multiply by another fraction in red, so that my denominators will end up matching. Okay? So see what and all of this is over h. Don't forget the over h portion. It's super easy to forget that when you're dealing with all this other stuff on top. Alright, so we've got to figure out what to multiply here and what to multiply here so that my denominators across the bottom will both match. Okay? And so once I show you, it should be pretty easy to see. I'm going to multiply my first fraction by x on the bottom, which means I have to multiply the top by x also to keep the fraction balanced. And also, x over x is equal to 1. So I'm just multiplying by 1 here. My second fraction, I'm going to multiply by x plus h. And if I do it on the bottom, I have to do it on the top as well. Now, where is that coming from? Well, let's look at what happens when we multiply so you can see the denominators. So if I multiply these first two fractions together, on top I get 2x. And on bottom, I have 5 times x plus h times x, which we typically write as 5x times x plus h. Minus, when I multiply my second set of fractions together on top, I get 2x plus 2h. I'm going to distribute on the top. You'll see why. And on bottom, I have 5 times x plus h. And you can see now that the denominators match. So the key to this is figuring out what to multiply by to make the denominators the same. Okay, so here's one example of how to do that. I'll do another example after we finish this one. And this is all over h. Alright, so now my fractions on top have the same denominator. That's important. What that allows me to do is combine the numerators. I need to subtract my numerators. So I need to take 2x minus this numerator. So this negative is going to distribute to both of those. So I get 2x minus 2h all over my common denominator, 5x times x plus h. So when you subtract fractions that have the same denominator, you subtract the numerators and you keep the common denominator. And again, this is all over h. So you see how this is dividing by h here. To divide by h is the same thing as multiplying by the reciprocal of h, which is 1 over h. So if you ever want to divide a fraction by something, multiply by its reciprocal. Okay? Alright, so it's getting better. It's getting cleaner. We still have a little work to do. So let's subtract on top. 2x minus 2x cancels. So now I've got negative 2h over 5x times x plus h, and that's multiplied by 1 over h. So to multiply the fractions, I would multiply straight across, giving me negative 2h on bottom, and this h would just be multiplied on the bottom. So you can write that step out if you want. So you'd have negative 2h on top, and on bottom you have 5hx times x plus h. But then, because everything's multiplication, you can just cancel the h's. So I'm going to cancel this negative 2 times h. That's important. This is multiplication, so I can cancel with this h that I'm dividing by here. And my final answer is negative 2 over 5x times x plus h. And that's my difference quotient for that rational function. All right, let's try another one that's a little bit different format, but the exact same concept. Okay, so here we want to find the difference quotient again for a different rational function, x minus 4 over x plus 9. Same setup. We have to do f of x plus h. Right, we have to do this f of x plus h in the top left. So that means I go to my f function and I replace my x's with x plus h's. So that's going to be x plus h minus 4 over x plus h plus 9. That's f of x plus h. That's what I get when I input x plus h. Minus f of x. Well, that's just the original function, x minus 4 over x plus 9. And that is all over h as well. That is all over h because it's the difference quotient. So now let's simplify. I need a common denominator. I could write an entire extra step, but I find that I'm rewriting the same things frequently. So I'm going to help myself out a little bit by just building in what I'm going to multiply by up here. Multiply each fraction by something so that my resulting denominators match. Now a common mistake here is just to multiply the second fraction by h over h. Don't write that down unless you want to take note that that's not what you want to do. If you multiply x plus 9 times h, you don't get x plus h plus 9, which is what you have over here. Okay, so that's not going to work. So what we need to do is for the denominators to match, this is kind of the worst case scenario. I have to multiply this fraction on top and bottom by x plus 9. And I have to multiply this fraction on top and bottom by x plus h plus 9. Basically, you're just multiplying each fraction by the other's denominator, because that, you know, they're going to match then. But in this case, there's not even a simpler way to do it. You have to do it that way. Whereas before, in the previous problem, we didn't have to do that. All right, so let's get busy now. You can see that my fraction up here in the top left after I multiply is going to have a denominator of x plus 9 times x plus h plus 9. And my fraction in the top right is going to have a denominator of x plus 9 times x plus h plus 9. The denominators match. That's what we're going for. The reason it's so messy is because my numerators. I have to multiply x plus 9 by x plus h minus 4. And that's going to be my numerator. Now, I could complain about it, but I'm just going to start doing it. It's a little bit of work, but I'm just going to do it. It doesn't actually take that long. So I'm going to distribute my x to all three terms here. So I get x squared plus hx minus 4x. Now I will need some more room for my numerators. So let me move this over a little bit. Then I'll distribute my 9 to all three terms. So I get plus 9x plus 9h minus 36. Alright, now I'm going to do the same thing for the second numerator. I'm going to distribute my x minus 4 to the x plus h plus 9. So I get x squared plus hx plus 9x. Then I'll distribute my negative 4 to get negative 4x minus 4h minus 36. Now that wasn't so bad. Maybe we weren't excited to do it, but it wasn't too bad. And don't forget, this is all over h. Okay, now we have to combine numerators. This negative, as we know, is going to distribute because I have to subtract this entire numerator. So every term here is going to change signs. Okay? When I combine my two fractions on top, my common denominator is x plus 9 times x plus h plus 9. And I'm dividing by h, which is the same thing as multiplying it by its reciprocal 1 over h. So all that's left is, what do I get when I take this numerator minus this numerator? Okay, so we're going to do all that at once. So I've got an x squared, and I've got minus an x squared. So those cancel because the negative distributes. I've got a plus hx, and I've got a negative hx. I've got a negative 4x, and I've got a positive 4x. I've got a positive 9x and a negative 9x. Remember, everything over here changes signs. I've got a positive 9h and a positive 4h. Now those are going to combine, so I'm going to keep those to give me 13h. And then finally, I've got a negative 36 and a positive 36, which cancel. Actually cleans up really nicely. Last, I'm going to multiply this fraction by 1 over h, and since everything's multiplication, I can cancel this h with this h, and my final answer is 13 over x plus 9 times x plus h plus 9. Now that's just a couple different examples of finding a difference quotient for a rational function, but the concept is the same for every difference quotient with a rational function. The key is, on top you've got to get a common denominator between the two fractions, and then to divide by the h, you multiply by 1 over h at the end. I hope this is helpful. You may need to rewind and watch certain parts of it again, but good luck. I know you can do it.